Today we are talking about climate change. You may have heard of global warming. We're going to use the words climate change and global warming interchangeably, meaning we're going to say they're the same thing, which they are. Scientists just used to use global warming a lot more often, and now they've switched to using climate change instead. And they feel that climate change is a better representation because not all of the parts of the world are warming or warming at the same rate. So instead, they talk about climate change because it encompasses a lot more of those changes that are happening around the planet. So the first thing that we have to talk about is the difference between climate and weather, okay? Climate are the weather conditions that occur over a long period of time. So for example, we know that we live in a temperate climate. So what that means is that it gets warm in the summer and cold in the winter. Some people live in a tropical climate where it's warm all year round, okay? And this is the climate that they live in. It doesn't change from year to year. Sure, it might go up a little bit or down a little bit, but as a general rule, it gets cold every winter and warm every summer here. All right. When we talk about weather, we talk about just what's happening today. Is it raining? Is it hot? Is it cold? Climate is over a long period of time, so typically 10 years or longer. So when people talk about, oh, this winter was really cold, so climate change can't be happening. Well, yeah, this winter might have been really cold, but at the same time, climate change looks at really long periods of time. So one winter or one summer is not going to make that big of a difference. Okay? What they look at is the trend over long periods of years, like over the last 10 years, over the last 100 years. What has the temperature been doing on average? So climate change then are changes in the Earth's atmosphere or the Earth's climate, and scientists attribute this to increased greenhouse gases. Okay, so we don't talk about climate change back in the days of cavemen because they weren't burning fossil fuels and they weren't producing greenhouse gases. Sure, the climate may have changed. It might have gone through a warming and cooling period, but we don't say climate change happened back then because the climate change we're talking about now is because of humans, okay? It's not naturally occurring climate change. So we'll talk about what greenhouse gases are in a second, but they're largely responsible for this increase in temperature. So remember the carbon cycle. All right, we talked about carbon is stored underground in oil, coal, natural gas. It's stored in the oceans. Okay, it's stored in plants when they do photosynthesis, and it's stored in animals when animals eat the plants. And then we said in order to get released, either these animals have to die, or burning fossil fuels can release carbon into the atmosphere. So climate change is mainly caused by increased carbon dioxide from burning these fossil fuels. They used to be underground, okay? When they were underground, they weren't in the atmosphere, they were underground. And so we didn't have to worry about them being in the air and affecting the atmosphere and the temperature of the planet. But as humans have used them in our cars and trucks and to generate electricity and in factories, we have basically burned them, and then some of those particles go into the air as typically carbon dioxide, but there are a couple other gases as well. And when the carbon dioxide is in our air, it alters the temperature. So coal and oil, gasoline, fossil fuels, those are all big contributors to this temperature change that we are seeing. And I'll show you how we can figure out that these these are the exact causes of the climate change. All right, so I'm gonna have you pause this for a second and we're gonna watch a video clip on the greenhouse effect, and then we're gonna come back and talk about it. So in that video, the greenhouse effect, they talked about how it was like a greenhouse, okay? If you've ever gotten in a hot car or a car on a warm summer day and it's really, really hot. That's the same thing as the greenhouse effect. So what happens is the sunshine, all right, goes into the car, okay, and it's a sun ray, right? And then when it hits the car in the inside, it transforms into heat. Well, some of that heat can go back out into space or out of the car, but some of that stays back in. So a car on a hot day is the same thing as the greenhouse effect. It's the same thing a greenhouse does. A greenhouse takes in sun rays, and those sun rays are transformed into heat, but the heat can't escape. Same thing happens on Earth. Sunlight comes in our atmosphere, bounces off of the Earth and some of the atmospheric molecules. Some of it goes back into space, but a lot of it stays in here. Well, when we have more gases in our atmosphere, more of this heat is going to stay in the atmosphere, and that increases the Earth's temperature. So the greenhouse effect. Carbon dioxide in the atmosphere traps heat from sunlight and prevents it from going back into space. If you've ever seen a greenhouse like this, it's the same thing. Okay, sunlight goes in, right? It changes into heat once it hits a surface inside here, but then the heat can't escape back out. Okay, it can't get back out, so that's why a greenhouse is a lot warmer. Now, like they said on that video, we have the natural greenhouse effect. So what does this mean? Well, we naturally have gases in our atmosphere that trap heat, and this is a good thing because our planet would be really, really cold without our atmosphere and without these greenhouse gases. But as you can see, some of these sunlight rays can go back into outer space when we don't have a ton of greenhouse gases. When we have a lot of greenhouse gases here, okay, a lot more of this heat stays trapped in our atmosphere, and so as a result, our Earth heats up a lot more than it would have normally. So what are some of the greenhouse gases, and what is a greenhouse gas? A greenhouse gas is a gas that traps heat in the atmosphere. There are a couple different greenhouse gases. The most talked about greenhouse gas is carbon dioxide. And if you look at this pie chart here, carbon dioxide is right here, and it contributes or it constitutes 82% of the greenhouse gases. So we've got carbon dioxide, 10% is methane, 5% is nitrous oxides, and 3% are fluorinated gases. So we're going to just go ahead and write some of these down. I'll explain a little bit more. So methane. Methane comes from sewers and landfills. Okay, that's the gas that's released when the garbage breaks down. It also comes from cows. Okay, so methane is a super powerful greenhouse gas, but we don't have a ton of it in our atmosphere. Okay, but it's really, really powerful. It can trap a lot more heat than carbon dioxide. Carbon dioxide, that's from cutting down trees, burning fossil fuels, factories, okay, using your car. Nitrous oxides, these are pollutions from smokestacks, okay? So nitrous oxides typically come from air pollution when factories burn things. And then the last one are fluorinated gases, which are abbreviated CFCs, okay? Now, CFCs, where they used to be super common in like shaving cream containers and hairspray containers. So in order to get shaving cream and hairspray to work, right, there has to be a gas inside of it that pushes the shaving cream or hairspray out when you push on the top part, okay? Well, they used to fill it with this gas that had fluorine in it, fluorinated gas. And then they realized that that was a greenhouse gas. And so now they don't fill those containers with CFCs anymore. They use something else. So CFCs aren't super common anymore because they were easily taken out of our society, okay? Whereas like carbon dioxide with fossil fuels, if we just took away fossil fuels, it'd be pretty tricky to run everything on our planet. So is climate change caused by human activities? Does it occur naturally? What's the deal here? Okay. Here is a fact. Climate changes naturally. It does. Okay. So if somebody's like, oh, well, climate changes naturally, blah, 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 we're not going through climate change. Well, yeah, they're partially right. Climate does change naturally without humans. So let me show you. So we've got, this is a graph here. Okay. So I'm going to get another color. So what we have here is a line, and this is time. So right here is 0. All right. We've got 2,400 years before 0 over here, and 2,000 years after 0 over here. So these little blue dips here are when the temperature was below normal. Okay. And these were little ice ages, dark ages, etc. And then over here we have periods where it was a lot warmer than usual. Okay, that's here we have Egyptians. This is when the Romans lived, the Vikings, and we're right about here. Okay, so climate changes naturally. And if somebody tells you, well, you know, climate changes naturally, we go through periods of warming and cooling. Yeah, that's true. Okay, but here's the deal. Recently, these changes are thought to be due to human activities, not due to the climate changing naturally. So how do we know this? Well, we're going to talk about the first piece of evidence for global warming or climate change. First of all, CO2 in our atmosphere is increasing, okay? So if we look at CO2 over here, okay, on the left-hand side, and this is 4,000 years ago, 200,000 years ago, and this is today. Okay, so notice CO2 goes up and down. Great, all right, but for the past 650,000 years, as far back as we can go, it's never been above this line, ever, ever, okay, until now. Here's where we're at now, okay? And this is actually as of July 2013, so we're probably a little bit higher than this now. But this just goes to show you that our climate, our atmosphere, has never had anything this crazy go on with carbon dioxide until now, okay? And this is when fossil fuels started to be burned, okay? So that's the first piece of evidence. And we're going to look next at how CO2 and temperature are related. So as the CO2 level increases, what does that do to temperature? Okay. So the next thing you're going to do is you guys are going to be graphing. Okay, you're going to be graphing CO2 and temperature. So it's kind of a funny graph. We're going to have CO2 over here. Okay, it says to go from 250 to 450. So we're going to count by tens. Okay, I'm going to type that over here. 250 to 450 by tens. Okay. Now, on the bottom here, we're going to have years. It's my awesome cursive. Years, okay? And the years, we are going to go by tens as well, okay? I think it starts at 1850. Don't quote me on that. 1850 to 2050 by tens, okay? And then the last thing you're going to do is when you're done with that, you're going to graph, and we're going to graph, they're going to be dots, and then you're going to connect them, okay? So you're going to have CO2 and the years. And then after you're done with that, you're going to make another axis over here, okay? And you're going to do temperature, and the temperature, I think it says to go from 13.5 to 15, and you're going to go by 0.01. So what does this mean? 13.5, 13.6, 13.7, 13.8, etc. And then you're going to graph temperature on this graph as well. You're going to have a line for CO2 and a line for temperature. So once you're done, it should look something like this.